Good morning, everyone, and welcome to our Offsite Manufacturing and Onsite Placement and Assembly session for Offsite Ready, the project that delivers knowledge for change. My name is Katrina Jordan, and I'm an architect and lecturer at the City of Glasgow College. We are a project partner in the Offsite Ready project. This is our third out of 4 training sessions of the series that are delivered jointly with Construction Scotland Innovation Centre. We're delighted that you have joined us today for an insight into offsite manufacturing and on-site placement and assembly. The content can and will equip educators in all areas of offsite construction. This flexible programme is free and easy to use. This morning we will start with offsite manufacturing, firstly with an overview of the subject, with an interview with Sam Hart, and opportunity for question and answer. Then we'll move on to on-site placement and assembly. Before we go any further, to ask a question, click on the chat icon in the control panel. It should be located at the right-hand side of your screen. Type the question and press send. We will answer as many questions as we can in our question and answer slots throughout the webinar. The webinar will be recorded and the link will be posted on our social network channels. Finally, there will be some polls throughout the webinar which we are keen for you to participate in. And after the webinar, there will be an evaluation form. Please complete this as it will help us provide you the best service we can. I would like to welcome our panellists today, Dr. Mila Duncheva from Napier University. Mila is the lead creator in the Offsite Ready content, and Sam Hart from Construction Scotland Innovation Centre. Before we go any further, we'll just take a look at our first poll. We're keen to find out which area you're educating in or training in. Is education construction, education built environments area, industry construction, industry design, or industry supply? The results from that poll is mainly from education, construction, and then the built environment education as a kind of joint second. We're now going to take a look at our first offsite manufacturing video.
The manufacture of systems and components for offsite project covers at least 40% of all building activities. Offsite construction makes use of a range of materials. Cassettes or large parts of structure can be completed offsite to varying levels. The offsite system used greatly influences the design and site assembly operations. Depending on the material and elements manufactured, the size of the factory and the manufacturing processes may vary.
The manufacturing process will differ based on the materials and the type of system chosen.
The manufacturing process represents the key difference between off-site and traditional construction. On-site methods of construction differ from off-site manufacturing in that off-site construction applies standardised component-based products manufactured in a factory environment. Off-site manufacturing within a factory environment brings a number of environmental benefits.
Factory operations allow off-site manufacturing to optimize the quantities, lengths and sizes of materials in the assembly of panels, pods and other components. This efficiency translates to less material costs, less material storage and faster processes. It also means less offcuts and less waste, and that's significantly less material then going to landfill. And in the case of processes involving unavoidable timber waste, these could be used as fuel for the factory's biomass or wood burning heating systems. Offsite manufacturing is an innovative method of construction. As such, the fundamental principles of sustainability can more easily be integrated into our workflows. It is vital that sustainability is embedded throughout the workflow and not seen as an add-on or a bolt-on. When fully considered and embedded, you will see that sustainability works to strengthen the advantages of off-site construction, design, manufacturing, logistics and assembly. Just as off-site construction seeks to enhance the construction process through optimization, so too does sustainability. So let's look at a few examples, starting with digital skills, applying design of services. Mechanical, electrical and plumbing elements are integral to the levels of energy consumed and carbon dioxide emitted from our buildings during their operational life. As such, we are seeing higher demand from public and private sectors to lower energy demand and CO2 levels from our buildings. This comes in many forms, from the older eco homes and Code for Sustainable Homes to the newer BREEAM and Scottish Building Standards Section 7. Design methodologies and compliance regulations now require more from the services inside our buildings. This allows the off-site construction sector to streamline the design and implementation of building integrated renewable technologies within the building's fabric. Sustainability also relates to the whole life cycle of the building, not just when the building is handed over to the client, occupied and used. The life cycle includes the processes to construct, deliver and deconstruct the building.
Off-site manufacturing also provides a single place of work, increasing the workers' quality of life and predictable daily commute. Off-site manufacturing provides protection from the elements, which can often cause delays at contractors' own cost. In addition, off-site manufacturing generally improves health and safety conditions through reduced needs for manual lifting and working at height. Being able to monitor factory productivity through asset tracking, sequencing tools and data sharing platforms. This allows off-site manufacturing to understand and improve on targets, milestones and foreseeable issues that are likely to cause delay. Before manufacturing can commence, the design needs to be completed in a design stage freeze. Changes to the design after the design freeze will likely cause rework with associated time delays and increased costs. In this respect, communication between the parties is essential. Competency of skilled workers is essential and must be reflected in training to ensure the correct and effective use of plant, machinery and power tools by meeting the appropriate health, safety and welfare legislation. It is important that skilled workers have a sound understanding of machine controls, limitations, tolerances, safeguards and risk controls for operation. And similar to traditional construction, can demonstrate knowledge of relevant legislation, for example, PPE and COSH. The factory layout sequences circulation, flow and location of vehicle areas. Routes and emergency exits must be considered. This demands the production to be sequential. If discrepancies happen, it will have a knock-on effect to the whole project, potentially disrupting time and cost and workflow. Off-site manufacturing processes are supported by the use of IT tools and building information modelling. BIM tools can provide manufacturing data files extracted from the design model to be used directly in semi-automated production equipment. Multi-skilling of factory operatives in the off-site environment facilitates the integration of job roles and promotes a more collaborative approach. The manufacturing process needs to be in sequence. In some scenarios, manufacturing may be undertaken near site to facilitate improved logistics, often referred to as flying factories. Due to ever-improving technologies, production lines may become faster and more efficient through automation. An example of this is to use a robotic arm to assemble a steel or timber panel from materials lining the inside face or fully clad the outside face. Manufacturing is off-site construction and is a substantial difference to traditional construction. Working in a factory environment can bring a variety of benefits, including reduced time, waste materials, and improved health and safety conditions. Multi-skilling operatives can greatly improve factory efficiency and smooth the flow of the production process. Increased levels of automation and more sophisticated machinery constitute future opportunities of the growth in this sector. Congratulations, you're now off-site ready with knowledge for change in off-site manufacturing.
I hope that gave you a good overview of offsite construction. Now we're going to move on to our next poll. Offsite manufacturing offers a number of environmental benefits, but what do you think is the most significant? Less waste, less material storage, less cost, or lower energy demands? Next up is our video with Sam Hart discussing the benefits of offsite manufacturing, and also he'll be discussing some projects that he has been involved in. So most people think most significant benefit is the reduction in waste, and less cost come in second. So now moving on to our video with Sam Hart. Hi and welcome to the Offsite Manufacturing and On-Site Placement and Assembly training session. Today we have Sam Hart from Construction Scotland Innovation Centre. Sam is an innovation manager, and Sam has a diverse background in construction, from running his own joinery company to operations manager at JML Contracts, where he's worked in offsite construction. Hi Sam.
Hi, how are you doing?
Thank you. So Sam, we just want to dive straight in to some of the questions around offsite manufacturing. How does offsite manufacturing differ to that of traditional construction?
I think probably the most significant difference would be how front-loaded it is from a digital perspective. To gain the main benefits from offsite construction, it's generally utilizes a computer or CAD design tool, which acts as a platform for the end user to be able to really understand the intricacies of the design and ensure that the accuracies of what you're going to produce are visualized before they're actually taken to the construction site. That in turn is then used through an automated modeling process that then speaks to the machines in the factory, which would be cutting and processing and developing the off-site elements, depending on, I suppose, the level of automation, robotics, and other stuff that you had in your factory. Might use machines like CNC machine, which will cut and route out some of the wall elements, floor elements, etc. And all of this now is tied into what's called a BIM model, has been promoted as part of the government's increase of digital technology, I think, since 2016. The main difference at that front section is just how loaded it is from a digital perspective.
Design perspective, yep. And in the Offsite Ready modules that have been created, offsite manufacturing covers some sort of key terms in understanding and monitoring and controlling resources, supply chain management, sort of quality assurance. Why do you think these skills are so important in offsite manufacturing?
I think the skills, the knowledge, and the behaviours for offsite construction are different to those of on-site construction, and the move to a factory environment results in probably increased levels of lean production philosophy and automation, and as I said before, possibly even robotics. So in order to realize those benefits, strategic planning and logistical optimization are needed through coherent management and, I suppose, management of the different phases of the activities on site. And I suppose it can be broken down into client and customer management. customers probably don't have quite the same amount of free reign on when it comes to offsite, because there has to be a design freeze. There has to be a point at which customers can't make any changes. They can't walk onto site and say, oh, you know, I'm not quite sure about this. Can we change that? You know, if things are being produced in a factory, a bit like car manufacturing, you can't walk into the car garage and say, actually, I don't want that on my on the car, it might be. So there's quite a strong element of customer management, I suppose. And then following through to that, there's the design management. So equally importantly, the architects, the engineers, the production facility, everyone needs to be highly communicative and talking to each other. And everyone needs to know that the tolerances that people are working to, again, if you are building on site, it's possible to, you know, shave a bit off here or cut a bit off here and try and make things fit. Whereas if you're bringing a completed floor of an apartment in, you know, the levels of tolerances are not the same. So everybody needs to understand the tolerances that each party are working towards. Similarly, program management. You know, if you are bringing modular units to a site, it might not be possible to store them. So if there are delays on site, you know, you can't just bring finished units and just drop them at the door and drive away. You know, all of that communication needs to happen there. And similarly, that transportation element, you might have to cross rivers, you might have to cross railways, get under bridges, all that sort of stuff. So from a logistical perspective, there's quite a lot of management there too. And I suppose finally, the most important, or one of the biggest benefits of offsite construction is the quality and accuracy. So that quality management system that you talked about and the assurance is intrinsic to the manufacturing mindset of being in a factory. And those tolerances and accuracy are just at a level that you couldn't achieve, you know, through on-site construction.
And it sounds like a kind of key role there is the collaboration between the parties, which, even though with building information modelling in traditional construction, there's still a gap there, whereas offsite construction seems to be really bringing it together now. Yeah, absolutely. I think, you know, and the more and more it happens, the more people understand how important that communication is, and how, you know, how essential, you know, the more each party does it, the smoother the transition gets, and the bigger the benefits go, you know, the more we do it, basically. Yeah. And just kind of moving on, thinking about health and safety. So how can offsite manufacturing improve health and safety in construction?
I think the most obvious benefit is simply the reduced numbers of people on site. I think the exact statistic is something like the manufacturing sector is something like 27% statistically safer than on-site construction. So by simply moving to a manufacturing facility, you're automatically more than a quarter safer. And I think that's probably due to the reduced number, you know, the inherent dangers that come with being on a construction site, like working from height, manual handling. You know, there's no cutting of things, so you have no risk of respiratory diseases. When the guys or girls are doing this in the factory, generally the facilities are probably better and more efficient. So whether or not, as I said, that's respiratory and breathing equipment, or welfare facilities, there's less dangers or hazards, should I say, I think, through the manufacturing process, and therefore that just means with less people on site, there's less danger.
Excellent, that's great. And talked about respiratory benefits there, and that kind of takes us on to other environmental benefits of offsite construction. Could you tell us about a few of them as well?
Yeah, sure. I think we give some presentations at CSIC, and I think some of the slides show construction accounts for something like 60% of all material and energy use across the UK, 60%. And it's about 30% of the water consumption. I think offsite construction improves tighter controls of materials through that CAD through the computer-aided design and manufacturing and automation. It offers tighter controls on that, so you tend to order only really what you need, because the computer tells you what you need, and in turn that reduces the waste that gets spat out the other side. So the lower resource inputs and the reduced waste outputs compared to on-site construction are really quite significant. I think the figures, the reduction in waste is somewhere in the region of 20 to 40% on-site versus off-site. So as I said, the efficient use of materials, that needs to be secured through a qualified supply chain who are able to deliver to you, obviously it's called just in time, just when you need it, so that you're not holding great swathes of stock that can get wet or warp or the other bits and pieces. So yes, similarly, I think from that environmental perspective, it's important that the designers understand the intrinsic benefits of the materials that they're offering, because one of the significant benefits of offsite construction is the improved thermal performance, acoustic performance, air tightness, and obviously you're not going to get all those benefits unless you look at incorporating the correct building materials, such as timber and it being able to sequester carbon and become a carbon store, etc. So the designers are quite important in that element too. But the research shows, as I said, the savings somewhere in the region of 20 to 40% on a waste basis. So significant.
Yeah, really makes a difference. And finally, would you like to tell us about a project that you've worked on that's adopted offsite manufacturing? Any experience?
Yeah, there's been quite a few. We did a small recording studio. So these were modules that were built in a factory, completely finished, curtains, blinds hanging, completely done. But then of course it's quite a small world, the music industry. So one person hears, and word goes down, and before you know it, you're suddenly doing these big lines of recording studios. We were working with a company that all of the musicians recommended, who are famous in California for supplying the kind of cushions or dampening that go on the wall to make sure the acoustics are all right. All of that sort of stuff. Similarly, from a civil engineering perspective, we've done hydroelectric schemes using off-site manufactured or pre-manufactured concrete shuttering. So I had to fly everything because of the locations. We've flown everything through using helicopters, which was quite exciting. And then I suppose the most recent at CSIC would be the Multiply project, was American Hardwood Export Council, Arup engineers and War Thistleton, big timber architects down in London, to produce something it was originally for London Design Week through tulip wood. Is an American hardwood that is perhaps considered in America to not be of the highest grade, but the engineers wanted to prove what could be done with it. So we created a project for London Design Week, which incorporated, I think it was about 120 CLT panels that were made in the Innovation Centre, and was cut and joined in a way that allowed it to be assembled and disassembled. So it then went from London to Milan, and then Milan to Spain. And there's a video online you could probably get the link to see that. So yeah, that's probably the most recent exciting one that we've done at CSIC. And then fingers crossed, more to come as we open up again.
Exactly, that's brilliant. It sounds really exciting work. Thank you so much, Sam, for joining us today, and thank you for your continual support in our Offsite Ready project.
You're welcome.
You. That was a great overview into offsite manufacturing. And we're just going to open up the question and answers now. So please post some questions, and the panelists will be able to answer. Mila, I just wanted to talk to you. Sam talked about different types at the end there, projects that he has worked on and different offsite systems. Could you maybe tell us a little bit more about the differences between maybe sub-assembly panelized systems and volumetric manufacturing processes?
Yeah, of course. Thank you so much, Katrina. This is a really good question. And I think it's quite important to understand offsite construction in general, because you do have all these options when you're doing an offsite constructed project. So the way I like to think about it is almost a continuous flow of products. Basically, you always start with the sub-assemblies. That is your key starting point, regardless what kind of system you're manufacturing most often. And that could be just your lintel for a window that's that's pre-made before you go on to making the panels, or it can be some steel C-sections which are connected to a smaller sub-assembly, or even just cut to size. And indeed, if you really want to, or if the project necessitates it, you can actually just use the sub-assemblies, transport them directly to site. And that's where Offsite starts to almost be on the border of more traditional construction, where you do a significant amount of the work on the building site directly. So after you make your sub-assemblies, you typically put them together and you make panelized systems. So whether that's timber or steel, you typically make the structural frame with all the vertical and horizontal elements, and you can do that either manually using traditional skills on benches, or you can do it semi-automated using one of the assembly lines, an example of which you can see at the Construction Scotland Innovation Centre. So after you've made your sub-assemblies, you've turned them into panels, and then afterwards, if you do want to continue, then what you do is assemble the panels into a three-dimensional box, and then construct your volumetric project. Often, many people prefer the panelized option we're seeing, especially in Scotland with affordable homes. So you often reach the panelized stage either open or closed, with insulation or without insulation, with membranes, and even lightweight cladding can be added in the factory for the panels, and those are then transported onto site. Now, if your project has a lot of repeatable elements, especially in mainland Europe, I've seen this in multi-story residential housing of the likes you see in big cities such as London, for example, you may want to go for the full volumetric option, which is where you have several rooms, typically basically in a three-dimensional object. And that's when really you need a lot of those traditional skills in terms of you need all the people who can do the plastering, the plasterboard and the taping. You need the electricians, the plumbers who can connect everything. You also need the paint to be added, the kitchen units installed, etc. So that's the continuous process, from the sub-assemblies, then you go into the panels, and then you form the volumetric units afterwards.
Excellent, thank you. And you talked about traditional skills there needing to be utilised, and we have a question for Robert, and it's asking, can you elaborate on how off-site manufacturing gives a great opportunity to encourage a more diverse workforce, and also thinking about people who are in traditional construction and want to maybe take that step through into off-site construction?
Yeah, of course, that's actually a great question. So in terms of the diversity one, I do remember when I first went to Canada a few years ago, I was fortunate enough to be part of the modular construction conference there, and we went to see a company called AccuBuild, and for the first time ever, we saw females in the factory environment. And it's probably a little bit embarrassing in terms that everybody was really excited to see females on the factory floor making roof trusses, etc. So we just couldn't stop taking photographs of them. But what that does show is that, because in a manufacturing environment, everything is more task orientated, so it's very much separated into specific tasks. Obviously, people have different skill sets, so that means that there's more opportunities for people to do less manual lifting as well, which helps. More regular working hours, less need to travel extended periods to building sites, which change every few months. So all of that is more inclusive to a more diversified workforce. And just to give a more home-based example, I had the fortune of going down to Ilke Homes, who welcomed us as part of the Offsite Ready project. And what really stuck with me there was an example of again a female who had been a pastry chef who wanted to reskill and upskill, and she was now the best taper in all the factories. She was absolutely brilliant. Nobody could even come close to her. So that's one example of, I guess, not only people from traditional construction skills, but also lots of varying skill sets can actually be adapted in the offsite construction environment. And Sam knows more about joinery, etc. But if you're a plumber or electrician and you want to get into offsite construction, the main difference would actually be, the working environment would be in a factory rather than on site. So there would be things like quality control to consider, and having that mindset of first time right. You always do it right the first time. You don't pass problems down the manufacturing line. But that also means that you have the opportunity to upskill. So there may be some new interesting
just maybe a little bit there, Mila. But thank you. That was really interesting. You gave some excellent examples. We have a similar question from Lucy. So, Sam, maybe you could pick up on how easy is it going to be for design and designers and engineer consultancies to be able to deliver a design suitable for offsite manufacturing if they have no previous experience in offsite construction? What do you think about that question?
I think certainly from the experiences in Scotland, all of the industry partners and companies that we've worked with have got in-house designers that will work with external designers to work on this, to ensure that the original design has been optimized, that where it can, elements can be standardized. They are, depending on the level of the level of offsite that you're taking, whether it's timber kit and it's Stuart Milner Robertson's, or panelized and CCG, or volumetric like Carbon Dynamic and MACA. All of those companies have in-house engineers, designers who will work with external partners to ensure that the designs that they create are suitable and can be turned in and optimized for offsite. And then similarly, if you're a designer and you haven't necessarily got the experience, but you want to gain the experience, then of course you've got the centres like Mila's at, headed up by Robert, where the whole thing is based around offsite construction, innovative structures, and full education programs around that. So I think the training's available, and if it's a case of looking at a system or a design that needs developing now, then as I say, all of the Scottish companies that we work with anyway have in-house designers that will optimize those designs.
That's excellent. Thank you, Sam. And I think we have another question. Just I can find it, sorry. Yeah, I just wanted to pick up on offsite construction. So if you were to kind of summarise in 3 main considerations for offsite manufacturing, rather, what would they be that people should think about? If you could highlight 3 main considerations.
Is that for me? Sorry.
Anybody open to both, either?
Well, from my experience of having worked on site on it, I think one of the, as I mentioned in the video, tolerances for me is one of the main considerations, because as I said, things are manufactured so precisely and so accurately via the automated process that you're within plus or minus a millimeter, and so the people that are working on site that are placing the foundations, for example, need to clearly understand that their tolerances need to match those of the manufacturing facility, because otherwise, as I said, you just have stacks and stacks and stacks of finished units waiting for those to be completed. And I think also to get the benefit of the repeatability of a production line, obviously standardizing as much of the product as you can makes sense. Every time you need to change a design, you're changing something on the computer. You might need to change nailing heads, screwing heads, etc. on the machinery, which slows down production. So that would also be a consideration for me. And as I said in the video, I think it's important that the designers ensure that the materials that are specified obviously work with the system and enable you to get the benefits that offsite gives, like the airtightness and thermal and the other stuff. Ensure that they work together to get as I say, to get all the benefits that offsite manufacturing can offer.
That's brilliant. Thanks so much, Sam. We're just going to move on to our next poll. What do you think the biggest benefit for skilled workers to move into offsite manufacturing is? Creating a single place of work, improving health and safety of their working environment, or protection from the elements. After the poll, we're going to have an overview of on-site placement and assembly video overview. And the results being improving health and safety in their working environment, and therefore encouraging people, I think, into moving into working in off-site manufacturing. And here's our overview video.
On-site placement and assembly is a critical part of the off-site construction process, in which the manufactured components interface with the building site. During this phase, modules and elements, after being manufactured in the factory and transported, are placed on site and assembled into their final locations. On-site placement and assembly offers a range of benefits in the construction industry. However, this also brings challenges which the industry must address. With most manufacturing carried out in the factory, the duration of the work on site is reduced compared to traditional construction, where all manufacturing assembly is done on site. Depending on the level of completion of components, time on site may vary. Open panels, for example, will require insulation, sheeting and follow-on finishes to be completed on site, whereas volumetric systems can almost plug and play with a minimum work on site. On-site placement and assembly off-site components provide increased predictability of off-site activities with a reduced labour force compared to constructing the whole building on-site. BIM and IT tools allow for construction sequencing to be simulated prior to on-site assembly. One of the main benefits of on-site placement and assembly is a safer and cleaner working environment compared to stick building everything on site. This can include access via internal staircases instead of scaffolds, reduced time working at height and in hot environments. There is also significant time and cost savings, such as reduced wastage, reduction in temporary works, reduction in labour costs, reduced plant costs, to name a few. Another key benefit can be the reduced construction time, especially in the case of precast components. This removes the need for concrete curing times on site, and in this way can streamline the construction programme. As a result of less time, site processes, plant and personnel on site, water and energy consumption may also be reduced. Demobilisation and clean-up of the site can also be reduced as there is less to be removed from site upon completion. Risks related to site activities are reduced. Quicker on-site operations limit the disruption to the surrounding area. On-site construction requires precise, accurate placement of components, modules and buildings prior to their full assembly. Challenges can arise if even one small component is placed incorrectly. Tolerances in high-rise volumetric construction are a good example of this, as a small vertical deviation in the ground level will result in a larger displacement at the top of the building. Assembly operations need to be planned and accounted at the design stage, with efficient communication between stakeholders throughout the full design and construction process. Skilled workers must have a working knowledge of other trades and specialism. On-site works are typically undertaken by a small team working collaboratively. This requires flexibility within job roles and a dedicated trades to undertake a variety of tasks, normally out with their remit. This requires significant investment in training. However, with the right skills and knowledge, many problems will be avoided. Collaboration and communication must be frequent and efficient. Placement and assembly roles require technical understanding of products and material, and also a knowledge of off-site construction is required. Assembly of modules includes lifting and handling operations, which need to be planned step by step to prevent risks and provide mitigation measures. Manufacturers shall be required to provide information to ensure safe lifting and handling of modules. Safe areas, barriers and personal protective equipment have to be provided, and crane method statements need to be followed strictly. On-site works are typically undertaken by a team of dedicated operatives working collaboratively. Operatives must be able to interpret, manage and adhere to the production schedules to ensure programme remains on track. They must be able to identify and implement corrective and preventative actions to avoid delays. The application of IT tools such as augmented reality and virtual reality can facilitate site installation of services and systems. For example, live inspection, which allows non-destructive testing to construction details and services. Augmented reality can also be used to identify discrepancies between the BIM model and the on-site project. Management of site activities can be supported by the use of innovative software packages. This monitors site operations and can instantly identify and log variations. The use of drones can be applied to carry out checks and inspection at a distance, without interfering with operations and improving health and safety. On-site assembly is part of the off-site project lifecycle when off-site components interface with the building site. On-site placement and assembly can reduce on-site programs of work in comparison to traditional construction. It also improves health and safety management on-site, dependent on the material and the system manufactured. A challenge, however, can be the stricter tolerances for assembly of off-site components compared to in-situ construction. Reduction in time for off-site improves the environmental impact of off-site construction and reduces hazards and risks. Assembly process can be simulated and, with the advancement of technologies, managing, monitoring and inspection activities can be carried out more easily. Congratulations, you are now off-site ready with knowledge for change in on-site placement and assembly.
We're now playing an animation video. Hope that gave you a good overview of on-site placement and assembly. Remember to please post any questions during our question and answer slot just now. We have our final poll coming in just now as well. Off-site manufacturing and on-site placement and assembly offer many benefits. Which do you think are the most significant? Faster process, so speeding up the construction time, improved health and safety, improving on targets, and reduced waste. Again, questions for our panelists today before we finish up this morning. Most people thinking that the faster process, speeding up the construction time, is one of the main benefits of off-site manufacturing and on-site placement and assembly. And just picking up on that, really, and Sam, in terms of the benefits and kind of key things that you need to think about in on-site placement and assembly, and I suppose off-site manufacturing as well, is thinking about sequencing, ensuring that sequencing is correctly, this kind of just-in-time, Sam, you mentioned just-in-time delivery. Is there anything that you want to elaborate on that, or any other kind of key benefits that people should be thinking about in regards to on-site placement and assembly?
I can maybe kick off with a very simple example. I was fortunate enough to be on site on the Yoka project led by CCG in collaboration with Master Architects and Urban. So that was the tallest timber building in Scotland, made out of cross-laminated timber construction. As Sam mentioned earlier, there was that challenge of getting the foundations and the floor slab with the same tolerances as the cross-laminated timber construction. But a very simple benefit regarding health and safety was the fast erection process meant that an internal staircase could be built so that all the follow-on trades could use that internal staircase instead of the external scaffold to bring all the materials up and down, etc. And that created a much safer working environment simply as a consequence of the faster construction time.
Excellent, thank you, Mila. We have another question coming in from Shaba. In assembling offsite components, regardless of the type of offsite adopted, what are the main challenges and how can they be managed and mitigated?
I guess from the direct assemblies, I think once the design has been agreed and you have your standardized system for putting everything for the manufacturing process, I think the biggest challenge is, it sounds silly, but for me one of the biggest challenges is making sure it continues to function effectively. It's a hungry horse. If you imagine if anything, if that machinery breaks or there's an issue or something stops, the entire factory stops. So it's really important to make sure that you've got the continual feed, you've got everything is maintained both from a legislative and maintenance perspective to ensure those machines carry on. And it was another point about the standardization. Each time you have to change a design, you have to stop your machines. Everybody, all of the operatives that are working in there have to stop. So just ensuring that one of the main benefits of the offsite manufacturing process is that the ability to continually have things running. So I think as soon as something stops that's where one of the biggest challenges. Historically I've found working in the sector.
Yep, thank you. And I think that kind of touches on a question from Lucy, where she's asking about if there's a bespoke nature in a project. Is it realistic for the capabilities of factories to deliver small-scale projects, refurbishments and extensions? I think that's something that we just seen in one of the animations, Mila, the Maca animation. So
yeah, exactly. That's exactly correct. So Maca, as well as I think your best bet for something like this would probably be the smaller manufacturers. I think it depends really on the business model. So people who are working at scale, who have a set product, they would probably see inefficiencies in the process if they have to produce a very small bespoke product for a refurbishment project. That doesn't mean they won't do it, but that is one of the challenges that they will face. Rather people like Maca, and as well as I'm sure there's one system which is basically imported from the Netherlands, who are all about retrofitting properties for affordable housing associations. So there's those two options, I think, for you.
And I know Bruce Newland's craft architecture, he's done a lot of bespoke one-off projects with offsite construction methods as well. The BRE Visitor Centre being one as well. This question's to Sam. And as an offsite consultant, what is your main work activities as intermediate between kind of architects and constructors?
I suppose from a CSIC's perspective as a consultant, my job is actually to bridge the gap between academia, industry and the public sector. So we're essentially funded by the Scottish Government, and we try to create collaborative projects that bring, as I said, industry, academia, and the public sector funding together to look at how we can solve some of the challenges that we've spoken about today. And those challenges may involve the industry partners may well be architectural practices, there may be engineers, there may be house builders, there may be small bespoke developers, they may be technology partners, and each of them will be trying to solve a challenge, and it's our job to put these projects together, manage them, run them through, and essentially bring them to the point of commercialization. But in addition to that, we do a lot of matchmaking. So we may have companies that come to us who say, who might be the best designers to help us with this, or engineers, or so similarly, if we are looking for academics, and with my background being around timber engineering, then obviously we're speed dial #1 to Mila and her team at Napier. So yeah, my job is really to try to bring those three parties together rather than working kind of directly within industry itself.
Yeah, excellent. Thank you, Sam. Someone's just asked a question. They've missed the webinar. So the webinar is recorded and it will be posted on the social network channels as well, just if anyone is curious about that. Sort of in summarising, so we've talked a lot, there's been a lot of comments in offsite manufacturing about reduction in waste and sustainability, and Sam, you talked about this 40% reduction in waste. Just to kind of summarise, could we maybe highlight some additional benefits offsite manufacturing and on-site placement and assembly, just for everyone to finish off?
For me, it would be the ability to manufacture through the quality assurance process. As I talked about, the tolerances and the quality that you can produce in a factory environment, you simply can't produce on site. There's the old adage that you'd never ask Ferrari to come and build your car on the driveway outside. Therefore, why do we ask people to go on site and build our houses for us? So for me, the main benefit is the quality of the product that is produced, the process that it goes through that assures that quality, yeah, I think that in turn will lead to a number of other benefits like customer satisfaction and improved payments and all those sort of things. It's going to knock-on effect. So for me, yeah, it's about the quality of the finished product.
Yeah, and just as a consequence is from that, Sam, one of those consequences you mentioned, that would be achieving your environmental performance targets. And very often we see increased levels of offsite systems, so fully volumetric or closed panels with a lot of items added in the factory are chosen specifically because they enable you to reach your environmental performance targets.
Yeah, I think that's a great point, Mila. The sort of the environmental benefits and building performance of offsite construction. So thank you both for joining us today. Some really great discussion and great points made. Yeah, I just want to thank everyone this morning. We hope you have enjoyed it, and thanks to our panelists for joining us. Next week we will have Neil Sutherland from Macker discussing the benefits of offsite construction and also discussing his offsite construction company, and then we'll also be finishing off with our final week going through the teaching support system, so how you can utilise the materials and how you can integrate them into your teaching and learning and training as well. So in the meantime, please visit our Offsite Ready website, so it's www.offsiteready.com, to access the teaching material that we will send out this morning as well. Can't wait to see you next week, and thank you everyone. Thank you, Sam and Mila.
Thanks for having us.
Thanks everyone.
Thank you. Bye now.
Bye.